All right, everybody. Welcome to this event. My name is Chris Snoring. I'm a Google developer expert, as Luca was saying. Today, we're going to talk about Rxjs 5. Last time I was talking about this, it was about number 4, so I've updated quite a few slides. There are some differences. Better now? Nothing? Anything? Now? Better. Probably the volume on my computer. Should I be muted? Hello? Should I be muting something? Probably this.
I know.
All right. Well, you can still hear me in here. Question is if someone else can. All right, let's kick it off. So as I was saying, we're going to talk about Rxjs 5 today. The inventor for that is a bunch of people, Ben Lesh amongst them. I think he's the team lead. Rxjs is about async programming. I guess you're all here because you're web developers, you're dealing with async, you find that it's a pain, and Rxjs has the mission to try to fix that. It's not a new library. As I said, Rxjs 4 exists. Rx exists in different flavors as well, for Java, for .NET, for different platforms, so you can use it on the back end. And nowadays, JavaScript is on the back end as well, now with Node.js. So why Rxjs in the first place? Well, async is a problem because you get these kind of callback patterns, right? And it kind of leads to callback hell. I will show you an image what that looks like if you don't know. But pretty much it's about trying to organize your async so it looks synchronous. It should look like any code out there that you call. And we want something better than promises. So the whole idea of Rxjs is that we tried out promises and they hurt for some reason. That's why we're here. Otherwise, we could just use the fetch API in the browser. We want one paradigm for async to rule them all, so we want to be able to treat all async concepts the same way, regardless of whether it's mouse clicks or AJAX calls or whatever it may be. So once upon a time in async land, there were callbacks, and those led to callback hell. So as you can see, we don't have a problem when we're dealing with just one async call and one callback method. But suddenly we have 4 or 5 calls that are dependent upon each other, and that's when we reach this callback hell. Let's ponder that one for a second. This hurts, right? Yes, we've seen this, and we hate it. So what do we do about it? Well, promises was a way to try to fix that. So here we have a service. It does a get data, and as you can see, we have subsequent dependent calls that does get more data, get even more, and so on. As you can see, the then is trying to structure our calls, but there are still weaknesses. Even though this looks more synchronous, promises have problems. Stop me at any time, by the way, if there's a concept that you want to hear more about, or again, if I'm talking too fast. I have double espresso here, so. So this looks great, right? But there are flaws. There are promise libraries out there with cancellations. I don't think cancellation is in the standard. I think it was removed even. We got other kind of async concepts, mouse positions, clicks, user inputs. All of those are async, which means we should be able to treat async concepts the same way. And that's where Rxjs really shines. We don't have any rich composition, and it's very hard to retry a promise. It's very ugly even when you try it in code. And it only returns one value. When you have that typical pattern of request response, that's it. That's all the values you're ever going to get. There are some data sources out there who are continuous, who keep on pumping data to you. For that reason, Rxjs is a better fit. And yeah, Brexit happened, and from today, as you all know, we got a re-election in place, 2018, right? So, well, this joke gets funnier and funnier, or more tragic. I don't know. You be the judge. Observables to the rescue. So observables is our lifeblood. It's the main concept in Rxjs. It's the one that we need to grok, the one we need to understand. So what is an observable? Well, an observable per se takes an observer and returns a function. An observer, on the other hand, is an object with a next error and a complete method. And when used in code, it can look like this. So here we are kind of creating our own observable. As you can see, we have a function that takes an observer. The observer does a bunch of calls, and we're pretty much done at this point. Looks understandable, I guess. I mean, we haven't complicated things so much yet. And we need to keep in our head that observables treat values as a stream of values over time. So as long as we remember that values will keep on coming, and it's not just the one value, it keeps on coming over time. This is a time axis. But of course, let's try to look at other concepts and see how an observable compares to those. So here we have an array, could be Lodash, could be the JavaScript itself. So here we have a list. We perform a map operation, a filter operation, and a take operation, and we end up with something that's more, that's better than we had before. A quick comparison to a promise, we can see that we have some kind of get method. It does an AJAX round trip, gets us some data. It calls then and possibly catch if there's an error. With that in mind, we have a look at the observable, and we can see that if you mesh those two, you kind of get an observable. Looking at the left here with the array, we see that we have a map operation, filter operation, take operation, and a subscribe that if you think about it as a then, it kind of makes sense. So if you're going from promises into Rxjs, you can kind of see that here's the async part of things. So remember that we do stuff with the response, and we try to subscribe to the response somehow. So if you want to try to remember what an observable is, think about it as a merge between those two with a little extra. Make sense so far? Great. See when the pizza kicks in and you're half asleep. But as I said, Rxjs and observables can also do cancellations and retries, which makes it very powerful, and it makes it promises on steroids in a way. So a manual creation of an observable looks like this. You call the create method, and you give it a function with an observer. And as you can see here, we have an observer that calls next with a value, which means that the first function parameter here in the subscribe is what is being triggered when we call next. And the same thing happens. So here we have two values emitted. This one is being hit again, once for each next, and so on. So next corresponds to the first function here. And let's have a look at the next again, but this time we emit an error. And this is where we hit the second callback in the subscribe. This is the fundamentals if you try to roll your own observables. So it's important that you understand when I do a next, what callback is being hit. Let's look at a complete example. So we emit our data, and we call complete. So in the first next, we hit this one, and in the complete, we hit this one. This is the very basics of observables. So as long as you get this one down, you're kind of good to go. Of course, there's a lot to learn about Rxjs, but this is the very basic if you try to create your own. Any questions so far? All right, great stuff. Subscribe to an observable. So of course, we want to be able to actually listen to the results of what we're trying to do. So in this case, we have created a stream. I should mention that the $sign is kind of a best practice when it comes to creating observables. So you kind of give it a $sign to say this is a stream. But you have your stream, you have created your observable, you call the subscribe method, and function value, function error, and function completed is what you're supposed to input to be able to listen to the different results. But of course, we want to be able to unsubscribe to an observable. I mean, it's a continuous data stream, and we might not be interested at some point. So we want to be able to do that. So what do we do to be able to create that? Well, if we create our own observable, we need to create our own dispose function. And in the case where we haven't created the observable ourselves, but we have used some kind of factor method, it suffices that we just call unsubscribe. So remember, once we have our observable, we are able to, sorry, this is actually a bit wrong. No, that doesn't work. But I wanted to say, let's see if I can just fix this real quick. This is the basics. So once we do this, sorry for the interruption, but this is a quite important thing to do. Anyone saw my error before I saw it? All right, everyone's clueless. Yeah, whatever works for you, dude. Okay, so back to the lecture. The difference here being that when I call the subscribe method, that's when it returns the object that we can unsubscribe to. So the important thing here is that we create our observable, and just after we created it, we kind of chain our calls. So we call subscribe. What comes back from that subscribe, that's the one that we call unsubscribe on. Make sense? Great. It's a fundamental thing. You don't want to get that wrong. So let's try to look at, we are on the premise here of trying to create our own observable, and we want to be able to unsubscribe to it somehow. So here we are calling the create at the top. We see that we have an observer that's being called X number of times with the next method, which means it's going to output a bunch of values here, right? So one for each value. But as I said before, if we want to be good citizens in observable land, we need to define a dispose function, something that cleans up after us. So here, the thing that the create returns is actually our dispose function. So what you can see here is that we set up an interval, right? And the way to clear an interval is to actually, sorry, I should say clear interval. I think you get what I'm trying to say here. But the main gist here is that we have something that happens in an async way, and we try to clean up the results. And when we call unsubscribe, it is actually calling the dispose function internally. So that's why it's so important that when we create our own observable, we need to define this function, because especially if we have some async thing going on, otherwise it's going to be like a memory leak and it's going to produce values forever. So it's very important that this function is in place if you roll your own. That's not so many, it's not so commonplace as you might think, but it's important to understand that basic. But as I said, the create method is not something that you're going to use every day. You're more likely to use a factor method that already exists. There are a bunch of those. So here you have an observable. You can either create an observable from an array of values, from a range, from intervals, from events, and so on. And this is what makes Rxjs so powerful. We're able to take almost any kind of async concept and just create an observable from it. So before you even think of using the create method, consider whether the factor method that you need already exists here. So check this list first. And of course, there will always come a time where you're not dealing with an observable at all, but you wanted to play nice with your other observable functions. So what you do to make that work is that you have to remember that the basics of an observable, or an observer in this case, is that we tend to the next method, the error method, and the complete method. So regardless of what async concept you have that's not in Rxjs, these are the three that you need to abide by. All right? This means that if we have like a vanilla Ajax call, in this case, when we get the data back, this is when we call next. All right? So we call observer next because we have gotten all the data. And we call complete because we know in Ajax land, we're only going to get one answer. So we know that we're done with the stream at this point. And of course, if something goes wrong, we need to handle that as well. And that's when we call observer.error. Or in this case, we have an error here. As you can see, if you're kind of awake, you see that we could possibly get 201 and we're going to treat that as an error. But the same principle remains. Next for emitting values, complete to close the stream, and error to handle errors. So regardless what async concept you come from, you can always wrap it like this. Make sense? Great. So, hot observables versus cold observables. There do exist such a concept as hot and cold, and it might be a bit much when you're entirely new to Rxjs, but it's good to know that they exist. So I'm going to talk about it real quick so you know what it is. So you've heard it at least once. Imagine that a hot observable is like that World Cup finale. Everyone watches at the same time. Everyone gets the same stream, right? You watch the World Cup finale. If 70 minutes have gone in the match, there's no way you can watch it from the beginning unless you record the transmission. But if you treat the hot observable as a live stream, you get the right idea what's happening with the data. Everyone shares the same data. Everyone, if you arrive at the game in the 70th minute, is not gonna, the football players are not gonna start from minute 2 again, just for you, right? As with the cold observable, it's more like a recorded TV show. Everyone gets their own copy. You can start and pause or fast forward whenever you want. So hot observables are shared, and it matters when you start subscribing. Observables are cold by default, but you can make them hot. You can make sure that they share their data. So what you have to do is, here we have created an observable, right? We have an interval, we have a take, and publish. The publish method here kind of warms up the observable, but it's not really going to be shared. It's not really going to be hot until you call connect up here on the right. So publish plus connect will make it hot. Otherwise, it's cold. So in this case, we have 2 users here that it actually depends when they subscribe. So if you look at this guy here, he starts subscribing straight away. He's going to get the data straight away. It's this guy, right? He's going to get 0, 1, 2, 3, 4 from the beginning. Whereas the other one, he waits 3 seconds. So because he waits 3 seconds, 0, 1, 2, it's already gone, right? He missed the first 5 minutes of the game. What he sees is 3 and 4. So it matters when you subscribe. If you're late to the party, you're going to miss out on the initial data. That's really important to remember when you're dealing with hot observables, is that it matters when you subscribe to them. Yes? I can repeat the question if you want. Great.
Okay. So I'm just curious what happened with cold observables, like when someone starts to subscribing in the middle, or if it's even possible to
it's
start.
Like that recorded TV show. If I record a TV show in my home, you do the same in your home. If you start watching your program, it's going to start from minute 0, right? If I start watching my programming, it's going to start from wherever I was. If I was in the 5th minute, that's where it's going to start. So my point is, with the cold observables, everyone gets their own publisher of data. So you will always get the data from the beginning. I will always get it from the beginning, because we are isolated. We have nothing to do with each other. So cold is kind of separated, whereas hot is shared.
Okay.
That answers your question?
Yeah, I think so, yeah.
Great, thank you. Keep on asking. It shows me that you're awake. Okay, there is, of course, such a concept as warm observables. They're kind of in the middle of cold and hot. So here we have the publish method that we used, remember, with hot observables, but we use something called a ref count instead. So the difference here is that this one will become hot. So it kind of warms up, right? It's waiting for something to happen. And what it's waiting for is the first guy to subscribe. So this is just lukewarm. It's just warm, right? There's nothing happening until this guy starts subscribing. Then suddenly it turns hot. So this is a really great way of trying to defer the values actually being emitted. When you want the hot behavior, but you still want to wait for that first person. So this is like you have your friends over, you're going to watch a game, and the first guy who presses play, that's when it starts. That's great. It's almost like a TiVo, right? There is also something called a share operator. The share operator is like a smart observable in the sense that it flips between hot and cold, and it becomes either hot and cold depending on what's happening. So what are these situations? There is a case when it becomes hot. This is when an observable has not completed, when a new subscription comes and subscribers are larger than 0. So this essentially means that someone has headed to your home, they have started to subscribe, and suddenly you enter. That's when it becomes hot. So before that, it's just cold observable. Why this might be important when these things happen is because hot observables are very resource intensive, so you might not want to use them all the time. It might make sense that something is shared, right? It's great for everyone to listen to, but it might be very heavy on your program, so you need to motivate, why do I need a hot in front of a cold observable? And also there are cases when it reverts back to cold, which is also great for memory reasons. So when the number of subscribers becomes 0 before a new subscription takes place. So this pretty much means if a subscriber unsubscribes, if the first guy that enters your apartment chooses to leave before you have a chance to arrive, it kind of goes back to being a cold observable again. And it waits for someone to subscribe, which means you're not going to miss out on any values, right? So, and of course, there is another case where an observable have completed before a new subscription has already been done. So this means that the entire match has passed you by. And that's when the other guy tries to come in and say, what's the score? Yeah, you can always, read about it later in the news. That's number 3. You don't need to, when you're new at Rxjs, you don't need to think about all these scenarios. I just mentioned that there are cold, warm, and hot. And I'm going to mention that at the end, the last slide, there is an Rxjs book, so you can take your own time trying to learn these concepts. So it's overwhelming today, just take your own time. It's a free book. I've started to write it. So let's try to summarize hot versus cold a second here. So cold, everyone has their own producer of values. The hot is, it shares values between subscriber, and it matters when someone's tried to subscribe, because that's when you're going to get the data. So if you miss out, you miss out if you're late to the party. And to make something hot, you use publish and connect. 2 guys. So you can create an observable from almost any async concept, as we said before, with different factor methods, remember? But there is such a thing in Rxjs that you will need to learn to master to some degree, and those are called operators. I've already mentioned some operators like map and take, but there are so many operators. I'm sounding like Trump right now, but in Rxjs 4, there were 120 operators. They kind of removed a lot of these operators because they were doing the same thing. I think now we're down to 60 operators, but that kind of sounds like a lot, right? You start with this library and suddenly, are you kidding me? 60 operators. But in actuality, you only need to know like 5 to 10 really important operators to be able to work with it. So take it easy. You don't need to learn all 60 operators. But if you really want to, there are references online where you can read about each and every single one. Don't know any .NET developers here? All right. So operators are like link, right? You have all these chained calls. So it's like link that's async, if that tells you anything. I think also there is the ability to do the same in Java, if there are any Java developers, when you kind of chain all the calls one after another. And of course, there is Lodash that kind of gives you the same idea. As I said, 120 operators became 60 operators. Thank you for that. And you got different categories of operators, so you can just cherry pick the operators that you think are valuable for you from each category. So you got conditional, combination, transformation, filtering operators, utility operators, and multicasting. That's a lot of categories, but you don't need to know all of them. Marble diagram is a graphical representation of what an operator does to your observable and your observable data. So if it's hard to grok when you read the description of the operator, you can always look at this graphical representation to get the idea what happens when I apply this operator, what actually happens over time. So if we look at a marble diagram, here we have a stream of values. We have another stream. And when I apply an operator, I end up with something that looks like this. So this looks like some kind of concatenation operator. But the thing you need to think about is what happens to the values, but what also happens to the time. So some operators do things with time, like a delay, for example. So it's not only about concatenating the values per se, but it's also important to keep track of this line, what happened here. So there is such a site called RX Marbles where a lot of operators are described. So you wonder what they do and you want to get a quick overview. This is where you go. Let's look at an operator example. Here we have the map operator. I think most of you know what it does. This one operates on each value and tries to do something with each value. In this case, I just add a 1. Here we have a filter operator that clearly removes values that are not wanted. So you can see we have this chain behavior happening. So operators map and filter were the ones we used. And as you can see, the end result of this observable starting with the values 1 through 5 is just 3 and 6 because of the filter operator. And of course, the map operator have ensured that our values are incremented by 1. The do operator, this is a very important one, especially in the beginning of your learning Rxjs, and because you're able to take each and every single emitted value and just log it out. So this is where you kind of put your debugger in a sense, right? So the do operator is very handy when it comes to see what actually happened because of all these operators being applied one after another. But it also matters where you put your do. So use this one for logging. Sample. This is a bit like talking to the hand, hence Arnold. In this case, we have a sample operator that ensures that we are being ignored for 2 seconds. So imagine a save button on a page. This is pretty much it, right? You try to do a lot of these clicks, trying to push save, and this is the case where we end up with a situation where it just blankly ignores us for 2 seconds before we're able to actually send an event again. So click, 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 click. After 2 seconds, this is when we start listening again. So this is a very handy thing to use, for example, a save button. Could be other cases as well, of course. Switch map. This one is really important. This is one of the few core operators that you really need to listen to. If you understand how this one works, you can do anything. The rest of the operators are just handy. This is one of the core operators for a reason. So here we have defined first off a break condition on a document click. And this means that what's happening inside of this is what's going to happen until a break condition happens. Sorry, I'm having this thing in the way. There's no way I can get rid of this now. No. Okay. So this means that these events here, they keep on happening all the way until this break condition happens. So essentially, till someone clicks on the page and say, click, that's when this stops happening and it starts happening from the beginning again. So this is like a restart, in a sense. This is not so usable right now from a business perspective, but it becomes really important when you're dealing with dependent calls. I'm going to show you that in another example. Switch map is really important because it deals with being able, so when you have a case where you try to return an observable within another observable, that's when you need a switch map. Flatmap, though, is like the cousin of switch map. It's not as competent as the switch map, but it essentially deals with the same problem, which is I have here an Ajax call where I fetch some JSON data and I want to return something within that to kind of change the observable in its nature, if you understand what I mean. I start out with something Ajax and I want it to become something JSON, for example. So essentially here I switch context, right? I start with a JSON that I fetch from the internet, and here you can say that suddenly I create an observable from an array instead. So this means I get an answer back that is a long array, let's say 300 rows, and I want to be able to emit every single row individually as one observable. If I didn't use flatmap here, I would get a list of observables, right? So what flatmap essentially does is it takes all the observables and merges them into one meta stream. So there's just one subscribe needed. Otherwise, I would need to subscribe to each and every observable here. So we don't want that. And that's why I'm saying flatmap and switchmap are very related, but I will show you exactly what switchmap does differently. But remember for now, switchmap, flatmap, that's what I need to keep track of. Those are core operators. But we use the flatmap instead of map in this case because we want to flatten our list, as I said. With just a normal map here, I would get a list of observables, and that would be very painful to handle. So as I said, it's great when you switch from one type of stream to another. Here, example, you have a bunch of events happening over time. Imagine that those are key ups or mouse clicks, and you want X number of key ups to turn into X number of Ajax calls, like you would do in autocomplete, right? And of course, you want your Ajax calls to turn into JSON. So here you can see that we have one type of observables that are events, and here you got another type of observables that are Ajax responses. So, and that's why I'm saying autocomplete is a very good match for Rxjs and the way it thinks. So what an autocomplete does is that it listens for keyboard presses. And we also want to be able to filter. So we only do a server trip if what we type in our autocomplete is different from what we have typed before. So imagine that we are typing ABC. We do one round trip by Ajax. Imagine that we type BB instead. That's a different call, right? But if we type ABC again, we want it to respond with a cached response instead of doing another round trip. That's very unnecessary. Unless, of course, we know that the backend is going to respond with something completely different. But that's seldom the case with an autocomplete. It's likely to be the same for days or weeks even. So caching is something we want. And we want to, based on all that input, we want to do an Ajax call. So, of course, we got the procedural approach. We got the non-Rxjs approach. This doesn't look too bloody, but it could easily be if you have a number of things that needs to happen. So in this case, we listen for a key up. We check if the number of entered characters is at least 3. At that point, we check the cache. If there's a response in the cache, we answer with the response. If there's nothing cached, then we do the Ajax. This is readable still, but it doesn't look as elegant as it could. So fetch if X characters long, return if cached, and do an Ajax if not cached. Makes sense, right? So the observable approach is all about modeling streams. Think about things as streams. So we got a stream of keys. You don't know when in time these will happen, right? A, 10 seconds later, B, 2 seconds later, or C, and so on. You don't need to care about when they happen, just that they do happen. We do want to do a filter, so we get a group of 3. We, based on that group of 3, we want to do an Ajax call. And of course, based on that group, we have some kind of response back that we are interested in that actually makes out the response list that the user sees. And we probably want to map the response so it becomes a JSON, so it's easy to read for the user. Given all that, we start by hooking up a key up. We do a little map, so we dig out the value from the event. We do a filter, so we say we're only interested if we get at least 3 or more characters. And this operator is so nice. This one is actually the caching operator. So this one says, if ABC is entered again, this means I will respond with the cache automatically. Otherwise, I will do an Ajax call. And of course, switch map in this case is used over flatMap. And we do the Ajax call, and we get some kind of response back. I will show you later why the switch map is preferred over flatMap, because it's entirely possible to use a flatMap here. They kind of operate in the same way, but there is a distinct difference that makes switch map preferable in Ajax cases. As you can see in this solution, it's a lot easier to read all the way from top to bottom. It's so easy to see. I do some kind of transformation, I transfer from events, I do some mapping, I do some filtering, I do some caching, and I do the Ajax call. It's like bam, 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 bam. Very easy. So let's talk about error handling a bit before we come back to why switch map is better than flatMap, because your streams will fail. And when they fail, you need to be responsible and handle that in a good way. So I'm going to show this graphically because otherwise it becomes a lot of code. But imagine that you have an error stream. You have something that does some kind of throwing of an exception, and that's going to break the stream. When you break the stream, your error callback in your observable will be hit, but the completion callback will not be hit. And that might be a problem. So what you can do to fix that observable is if you call .catch on it, then you have the ability to define what am I going to do with this error. So you can either return another observable because that error happened, and you kind of patch the observable. That means if you do this kind of patching, that means you're going to reach completion if that's important for you. If you have a case where you have two different observables coming from two different contexts, imagine that this one comes from one API and this one comes from another API. You know that this one will eventually fail. So what you can do here when you try to merge them is that you place a catch here. It's not perfect to place the catch there. You will reach completion, but because this one was merged in first, it matters when the order in which they are merged matters. So what will happen in this case is that it will reach completion, but this one never has a chance to meet any values. This is a good stream, by the way. Which means if I place the catch before these guys are merged together, if I kind of patch this error stream before, then we will come to a case where we reach completion and we get values from the stream that behaves. Of course, the crashing stream, is dead in the water. There are other approaches. I'll show you that. So here we have a case with two error streams, one functioning stream. We will reach the error callback, we won't reach completion, and we won't get any values because the error stream happens first. In the other case, this is a little bit like survival of the strongest. This middle stream here will say that if an error happens, just throw the error stream to the side. And if this one happens, throw this one to the side and let the one that actually functions come to a completion and make sure we get the values. So this is another way of handling your errors. So either this method or use a catch in a good place. It's a lot to take in, right? Let's breathe for a second. Is the air good in here? All right. So here we have the retry operator. Of course, this is very important. Imagine that you have a shaky connection. We've all done that Ajax call that doesn't work. And 2 seconds later or half a second later, it suddenly works because, internet goes up and down, or there are some internal reason why the API starts off with an error. If you know this is your situation, the retry operator allows you to do X number of retries before it actually gives up, which means it differs when it calls error. So unless the number of errors, if the number of retries have not yet been hit, that means that the error callback has not yet been hit. So it is actually like buying yourself time with the retry. So here it does 2 attempts of retry. And each time it does a retry, it retries the whole data stream again from the beginning. It's kind of hoping that there will be a different result. So depending on what is actually causing the error, this might either be a stupid reason or it might be a good reason for doing a retry. Imagine that there is another retry. This one is more credible, I think, when it comes to Ajax, because if you have the situation with a shaky connection, you probably want to wait X number of milliseconds before you try it again, if the reason for the error in the first place is that it comes up and down. So what you do in this case with the retry when is that we actually do a delay on the error. So here we say 200 milliseconds delay before we attempt another retry. So if the problem is a shaky connection, this will actually work on the second or third attempt or whenever you try to do it. So remember that retries are one of the things that makes Rxjs really great, and there's not a lot of code to do this. That's needed. So what have we learned so far? We can cancel our observables with the unsubscribe. We can retry easily. That was not a lot of code. A stream generates a continuous stream of values. Operators manipulate either the values or the streams themselves. Remember operators? And we can patch error streams with a catch, or we can use on error resume next if it's like the survival of the fittest, if we don't care what happens to the error streams. Schedulers is a quite advanced topic, but I'm going to mention schedulers in the context of tests because that's when they really shine. So schedulers have their own internal clock, which means they can bend time. So if you use schedulers in the context of testing, as I said, they can decide how fast the time passes. Instead of the time actually going 10 seconds, imagine that you can just increment 10 seconds like that. Then you can actually use them for testing. So we can bend time. And testing has changed a bit since Rxjs 4. So now they use something called marble testing. So remember that we had something called marble diagrams, a graphical representation of your observable. If we use marble testing, that means we do some kind of graphical testing on our observables. Here we have the entire test. It might be a bit to read, but I'm going to try to decipher it as best as I can. So imagine that here at the top, at the one called HS marble, we have defined a pattern, what we expect. So here we have an XYZ. XYZ is values that are going to be emitted. We have an expected variable that says, I expect this to happen. So what you do here is you create a hot observable. As you see, we put in our hot observable here in my algorithm, and it kind of uses this scheduler, this test scheduler that it creates. It inputs this here. So a lot of operators out there in Rxjs 5 takes an optional scheduler, which means that you can replace how fast time passes. So in this case, we are comparing the actual stream to the expected stream. So this is pretty much the setup for each and every single Rxjs test you're going to do. So as you see here, this is more graphical in its nature. But of course, there are hyphens, there are X's. What kind of symbols are there? I'm going to explain what symbols that you can play with, and it actually matters how they are lined out. Let's look at another example first. Here we have a very similar one, but I'm going to let you see. Do you see the difference? All right, so the difference here is in the expected. It has another hyphen. And the reason it has another hyphen is a hyphen means time has passed, right? Do you guys say hyphen or dash, by the way? Hyphen, right? Great, I'm in Britain. So, as you can see here in the filter, we are saying we don't want each and every single value, but time still passes while we filter away values, right? Which means that's why we add another hyphen. So instead of saying a value happens here, we say nothing happens here. That's the difference. That's the reason why we add a hyphen in its place and saying no value here, but time actually passes. So that's kind of expected with a filter. And let's look at an error case. Let's first explain the symbols. So the hyphen here means something. It's a time increment. So for every hyphen you do, you say that time passes. There are other symbols. I think there are 3 symbols that you need to learn when it comes to marble testing and testing generally. It's the hyphen, which means time has passed. It is, sorry, me being a Swede, what do you call this? Hashtag, thank you. I should know, right, Twitter. So the hashtag here represents an error. So when you describe how your observable behaves, the hashtag says error. And this guy here, the pipe, says a completion is going to happen. So let's put those in use. And let's say that, well, there's going to be a time increment, the hyphen, and there's going to be an error. So if we look at the hot observable that we're trying to create, we are essentially saying that our marble up here is going to say crash. So the first marble here is saying, well, I'm going to have a time increment, then I'm going to crash. And then you create an expected thing that's going to say, yes, time increment and a crash. So if we look at the observable that we have here, we see that we have an erroneous observable because it has a throw method. So we know for sure that this one is going to crash. So when we compare the actual thing to the expected thing, you can see that this is the expected result, time increment and crash. So remember the hyphen, the hash, and the pipe. So you define your behavior firstly. This is what I want to happen, and this is my expected thing. And these are the 3 symbols that's important to remember when it comes to marble testing. That's not a lot, right? 3 characters. And yes, from the book, you can just copy-paste all these tests if you want to have a setup when you start with this. So let's come to the fact why SwitchMap is better than flatMap. Let's try to first take a deep breath and think about the fact that, yes, okay, I am on promises, but do I need Rxjs? That's a very good question. Another good question is, let's say I buy into this. Let's say I think Rxjs is great, but I know how to do a bunch of stuff in promises, but I have no idea how to do the same thing in Rxjs. If I'm going to talk to my teammates or my CTO, whatever, I need to be able to tell him or her that I can actually recreate everything we have in Rxjs. That's the first buy-in, right? If I can do the same, then of course I'm in a better place. So let's see what that looks like. So in this case, we have a promise, right? We have a get data and a then. As you can see here on the right, we have the corresponding Rxjs code. We have a subscribe instead of the then, but otherwise they are one-to-one. And of course, I got the error callback on one side, the error callback on another side. But let's say we have a dependent case. Let's say we first want to fetch a user. When firstly we have that user, we want to fetch that user's orders. So we need to wait. We can't do this one unless this one has completed first. So we have a dependency. Fetch user first, then the order. And once we have the order, let's fetch the order item. Clear dependency. We know what that one looks in promises. We have the get user followed by get order by user followed by get order item by order. We know what this looks like in promise land. But if we have a quick look here at Rxjs, we see that we use switch map statements that are chained instead. So this is pretty much one-to-one here. We fetch our user, we kind of cheat, so we kind of respond with the user straight away. Once we have the user, we do a get order and a switch map. Once we have the order, we're able to do a get order item by that order. So chain switch maps will replace this kind of dependency calls. There's another case. Let's first say why switch map is important. Imagine that you have started to fetch the first user from a drop list, right? You've started to fetch the first user, Adam, and you want his order. And based on that order, you want to fetch an order item. But what if that user is fast enough to say, hey, I want to fetch Lisa's orders instead? You haven't locked that drop list, right? So the user suddenly switches from Adam to Lisa. You need a way to cancel that first operation. Otherwise, you're going to have 3 or 4 dependent calls happening. That's why you use a switch map to be able to abandon. If you use a flatMap in this case, you will just carry on with the 3 dependent calls from the first user that you don't care about. So switch map gives you the ability to say, I don't care about these dependent calls anymore, but I only care about this new selection that you did, because the preconditions have changed. This is why you use switch map. So if you have colleagues out there that see you do flatMap, they're going to be, switch map is a lot better. But you heard it from me. This is so you're able to abandon the first line of events. That's why you use it. Imagine that you have a dependent case, but not quite like the other dependent case. The only dependency you have really here is the user. These 2 guys, they could be fetched in parallel. Orders and messages could be, fetched independently of each other, but they do rely on user to be fetched first. A bit different from the first one. So in this case, we have another case of cascading calls. If we were to use a promise here, we'd be using the all method. We would be fetching users and orders and messages in parallel. The same thing to do in Rxjs land is to use a fork join. This is a one-to-one. These are probably the 2 situations that you need to be able to handle in Rxjs if you're going to be able to rewrite your code from promises to Rxjs. And this is the way to do it. The last summary, I promise. It's been a long day, right? So we can use schedulers to easily test our code, remember? We can do cascading calls quite easily. We should use switch map over flatMap when we're doing AJAX call, so we can abandon that first stream. And of course, if you fell asleep after 5 minutes, this is the book, so you can read everything in your own time. Angular.io/resources, Rxjs Ultimate. I think I've completed the book to 60%, so there's still a lot of materials in there. Of course, this is the official documentation. I will share all these slides with you. I will put it on SlideShare, I think. But this one is good. Read it in your own time, and I do understand if it's way too much. Thank you.
Any questions?
I'm ready to throw the microphone at people with questions, so that's for the recording. Thank you.
So you talked a bit about promises and callbacks and what that compares to to Rx observables. What about the async and await keywords? Does that mean anything for Rx observables as well?
That's a good question. Well, async or await keyword is implemented in generators, if I remember it correctly, at the present. Yeah, I think a lot of people who are in promised land, they tend to go to async as soon as they can. So they kind of set up the transpilation for it. So they kind of already have the synchronous experience. So if you're there and you only have request response kind of patterns, then I would say go with await. If you feel you have the need to do a lot of delays or retries, if you have that kind of problem, you should go with Rxjs or Bacon.js or similar frameworks. I would say await is the better way to go if you're dealing with promises and you have a very simple async experience. I've seen a lot of people go into await. Do you agree?
Yeah, there are, let's say, I think that the underlying thing is that promises and observables are slightly different, because one is more flexible and you can apply not only for retrieving a single operation, but also to create an entire architecture potentially. The other one, promises, are mainly when you want to handle asynchronous call or operations. So when you're dealing with, I don't know, operating system or Ajax calls, stuff like that.
Yeah, so it really depends on whether you're working with cool architectures like Netflix or maybe Lucas company. You guys are doing awesome stuff, right? Any more questions? All right, have a look at the yes, please.
Back to the concept of hot and cold observables.
Yes.
Is my understanding correct that hot observables, they share memory, and it's more well, it's better to use them for in case I would like to use a shared resource for reading some more reading operations. What about so I don't have an understanding what the applications of hot observables in real life. What about writing, or what about some use cases when we post some data and there are several subscribers? And in general, this example with TV show, live TV. So could you give more examples of using hot, and when we need to decide to switch to hot observables?
Yeah, exactly. I mean, I think in a lot of cases where you care about what's happening in real time, I think multiplayer games is a very good example. It's really when you have asynchronous streams happening and you all care about the data is correct at that point in time, and you care about listening in, and you don't mind so much that you missed stuff, right? So this is going to sound like a funny comparison, but imagine that you're comparing it to UDP, for example. You have a protocol that just sends a lot of data, like radio broadcaster, for example. I mean, there you have that behavior of just sending data, and you don't care about what happened in the beginning, but you care about when I start subscribing, I care. But before, whatever happened to the history, you don't really care. That's, I think, where hot observables really shine when it comes to good live cases, if you will. But yeah, I would say most of your cases are cold. Yeah, I think if you find a case that is supposed to be hot, you're probably dealing with something that's happening in real time, I would say.
No, it's I'm seeing you well. You are echoing. That was at the beginning of the meeting.
It's more of a.
Okay. So if there are any other questions, thank you again, Chris. It was. And thank you guys. If you want to remain here and I don't know, talk with Chris or with other guys, no problem. We still have pizza and we still have beers.
I'm gonna be here for a while, but. I just want to say, I'm not trying to promote the book to sell it. It's completely free. It's always going to remain free. So it's a community resource. So that's why I really want you to go in there and have a look and read in your own time. If you want to contribute, even better. So I'm always happy to have co-authors.
I think I need to press stop recording.
Yeah.